channel. Maths 2A Chapter 2 Exercise 2B. In the previous video, I have solved the first Roman 1 to 5 complete problems. Now let's proceed with the sixth problem. In the sixth problem, it is given that 1 omega and omega square are the cube roots of unity, and we have to find the value of the given questions from 1 to 7. So let's solve those questions and find the values of those. First question, a plus b whole cube plus a omega plus b omega square whole cube plus a omega square plus b omega whole cube. We know that a plus b whole cube is nothing but a cube plus b cube plus 3a square b plus 3ab square. So by using this formula, we will expand these things given to us and solve this problem. A plus b whole cube, a cube plus b cube plus 3a square b plus 3ab square. A omega plus b omega square whole cube can be written as a omega whole cube. This is a term, this is b term according to the formula if we consider, or you can consider xy also. So x cube, that is nothing but a cube omega cube, right, plus y cube, b cube omega square to the power 3 will become omega to the power 6. That is, I am showing it here. This will become b cube, this will become 6, omega to the power 6, plus 3a square b. So a square omega square b omega square as it is, we will write the b term and here a term is squaring, plus 3ab square. What is b? Sorry, a omega is here, a omega b square omega to the power 4 you will get. Now if we expand the third term, we will get it as a cube omega 6 plus b cube omega cube plus 3a square omega 4b omega plus 3a omega square b square omega square. Okay, now we know that omega cube is nothing but 1. So wherever we have omega cube, we will consider there to be 1. Also, we know that omega to the power 4 is nothing but omega cube into omega, which is 1 into omega, which is omega. And similarly, omega to the 5 will be equals to omega 4 into omega, that is omega into omega, omega square, and omega to the power 6 is omega to the power 5 into omega, which is nothing but omega square, right? Omega to the power 5 is omega square into omega, which is omega cube, which is 1. These values will get in the further when we solve. That's the reason I am writing it before only. I will show you why I have written this. Here we have a cube and a cube, so 2a cube plus similarly we have 2b cube terms, right? Then plus, now we will take this 3a square b common. Okay, 3a square b common, we will get 1 plus, again here you have 3a square b term, so we are left with omega to the power 4, isn't it? Omega square into omega square, omega to the power 4. Okay, then again a square b term, if we consider it is this term, omega to the power 5 will be left. That's the reason I have written here what is omega to the power 4 and what is omega to the power 5, because we have got here omega to the power 5 and omega to the power 4, which we can substitute from here. Then can solve the problem. It will be easier. Then now what I am going to take common is 3ab square. If I take this common, what are the terms I will be left with? 1 plus omega 5 plus omega 4, again the same thing, right? Then we are left with the next terms, which are nothing but, I write it here, the left terms are a cube omega 6 plus b cube and omega 6. Omega 6 is 1, we will substitute here 1. Omega to the power 5 is omega square, omega to the power 4 is omega. So in place of these values, we will substitute these values. Okay, so what we will get if we substitute? 2a cube plus 2b cube plus 3a square b, 1 plus omega square plus 3ab square, 1 plus omega square plus a cube plus b cube, which will give us 3a cube plus 3b cube, which can be written as 3 of a cube plus b cube also. So in this way you can solve the first question of the 6th bit, and this is the answer. The second question of the 6th bit is this. Now here we have to apply a plus b whole square formula, that is x plus y whole square, which is equals to x square plus y square plus 2xy. We know this formula will use to solve each term to get the final answer. So the solution is nothing but a plus 2b whole square can be written as a square plus b square, that is 4, 2's are 4, so 2 square is 4, 2 square is 4, b square plus 2a, b term here is 2b, right, plus a square omega 4, because a omega square whole square is nothing but a square omega 4, omega to the power 4, plus 4b square omega square, right, plus 2a omega square into b omega, 2b omega. Then this term, if I expand, I will get a square omega square plus 4b square omega 4 plus 2a omega b, 2b omega square. Final what we will get is a square plus 4b square plus 4ab plus a square omega 4 plus 4b square omega square plus 4ab omega cube plus a square omega square plus 4b square omega 4 to the power 4 plus 4ab omega cube. Right, now here omega to the power 4 and omega cube can be substituted, that is nothing but, since omega cube is equals to 1, omega to the power 4 is omega cube into omega, which is equals to omega. So we'll substitute omega cube as 1 and omega to the power 4 as omega. So if you substitute, we get the equation or the question when we solve as 4a square plus 4b square plus 4ab as it is, plus here you will get a square omega plus 4b square omega square as it is, then plus 4ab we will get, because omega cube is 1, plus a square omega square plus 4b square omega plus 4ab, right. Then if you look at this equation carefully, here you can take a square common, b square also common, right. So if I take a square common, I will be left with 1 plus omega square, and if I take 4b square, I can take common actually, right. 4b square is there, 4b square term is there, 4b square term is there, so I can take 4b square common and taken 4b square term common. I will be left with 1 plus omega square plus, that is these terms, plus omega. Now here we have 4ab, here also we have 4ab, here also we have 4ab with all positive signs. We can add these three terms, we will get it as 12ab. Now we know that 1 plus omega square is equals to 0. Therefore this is 0, this term is also 0. We'll be only left with 12ab, and this is the answer. Done. Now the third question. For this we have to use a simple condition, that is 1 plus omega square, which is equals to 0. Okay, we know this condition when 1 omega and omega square are the cube roots of unity. Here what we will do is we will consider 1 plus omega square, that is I'll write and show you. I'm writing 1 plus omega square, then I'm writing minus omega term. Okay, now from this condition we can substitute 1 plus omega square, isn't it, as minus omega. So if I simply substitute minus omega, I'll get like this condition, minus omega whole cube. Now minus omega into minus omega is what? Minus 2 omega whole cube. That is nothing but minus 2 whole cube and omega whole cube. Minus 2 whole cube is minus 8 and omega cube is 1. Therefore the answer will be minus 8. Wasn't it simple? So this is the final answer. Now the fourth question, 1 minus omega into 1 minus omega square multiplied by 1 minus omega to the power 4 multiplied by 1 minus omega to the power 8. This is this problem which is similar to the one of the problem I have solved in the fourth bit, second one, that is nothing but this is similar to that only. I will show you how to solve this. So for this we will first to see what we can write omega to the power 4 as and omega to the power 8 as. So omega to the power 4 can be written as omega cube into omega, which is 1 into omega. Therefore omega to the power 4 can be substituted as omega. Omega to the power 8 can be written as omega to the power 4 into omega to the power 4. When we can multiply this. In multiplication, when bases are same, powers can be added. So we can add this, we'll get 8, right? Omega to the power 8. So I'm splitting it in as omega to the power 4 into omega to the power 4. Now omega to the power 4 is nothing but omega into omega, which is omega to the power square. So omega to the power 8 can be written as this, that is omega to the power 2. Therefore if I write it 1 minus omega square, 1 minus omega and 1 minus omega square again. Now 1 minus omega is 2 times, 1 minus omega square is also 2 times, that is nothing but 1 minus omega into 1 minus omega square whole square. Now this can be multiplied, so 1 minus omega square minus omega plus omega cube whole square, which is 1 minus omega square minus omega plus 1. Omega cube is nothing but 1. So I have substituted this value. Then since 1 plus omega square is equals to 0, minus omega square will be equals to 1. I am sending these both terms that side, so I will be left with 1. So I can substitute this also as 1. So 1 plus 1 whole square, which is 3 whole square, which is equals to 9. So this is the answer. This is also a simple problem, right? This is the fifth question, which can be solved in this manner. It's a bit lengthy, so I will suggest you to practice it well. So it's a lengthy one, but it's also easy. So in this way you can solve it, right? Now let us solve the sixth question. It is given that 1 plus omega whole cube plus 1 plus omega square whole cube, This is the question we have. So what we are doing is, we know that 1 plus omega square is equals to 0. Therefore 1 plus omega can be substituted as minus omega square, and 1 plus omega square can be substituted as minus omega. So we are substituting simply in this way. We'll get minus omega square whole cube plus minus omega whole cube, which is minus omega to the power 6 minus omega cube. Omega cube is 1. We know that, right? Omega cube is 1. Therefore omega to the power 6 is omega cube whole square, which is again 1 only. So minus is the sign we have here, and this is 1. Okay, so minus 2. This is the final answer. Now the sixth question. 1 minus omega plus omega square to the power 5 plus 1 plus omega minus omega square to the power 5. We have to solve this. So for this, first we'll again consider this condition that 1 plus omega square is equals to 0. From that, what we'll find is 1 plus omega square, which can be substituted as minus omega, and in a similar way 1 plus omega can be substituted as minus omega square. If we substitute it, what we'll get is minus omega to the power 5 plus minus omega square to the power 5, which will be equals to minus 2 omega to the power 5 plus minus 2 omega square to the power 5, which is nothing but minus 32 omega to the power 5 minus of minus 32 omega to the power. Here this can be multiplied simply, so it will be 10. Minus 32 omega to the power 5 plus 32 omega to the power 10. Here we can take, here it is plus sign, by mistakenly I have written as minus, so here also you'll have minus only. Okay, I have by mistake taken as minus, here I have made it plus now. So here you can take minus 32 common, and you'll be left with omega to the power 5 plus omega to the power 10, which is nothing but omega to the power 5 is omega cube into omega square, 1 into omega square, which is omega square only. So I'm substituting omega square here, and omega to the power 10 in the similar way. If I say is omega to the power 9 into omega, which is omega cube whole cube into omega, which is omega again. Substituting this as omega. Now minus 32 into, from this condition, omega plus omega square can be substituted as minus 1, so simply substituting as minus 1, the answer will be 32. So this is the final answer. Thanks for watching the video. Do like, share, comment and subscribe. Don't forget to hit the bell icon.